Perfect. I mean, it's 2 o'clock. Good afternoon, everyone, or good day, good hello, wherever you are sitting. Thank you for joining us this afternoon, where we're going to guide you through a few key points of the new software release, Amberg Tunnel version 2.25 and Amberg Tunnel Navigator version 1.25. Before we start, quickly, a housekeeping session, a few words to the housekeeping. So, questions, please contact us via email because we have only set for 45 minutes max. So we would like to really go through. We have a lot of things to talk about. So if there's any questions left, please contact us. You will get the contact details after the webinar. So please contact us after that. So write down your questions and send us an email. And for those who will not be able to attend this afternoon, we distribute the recording after the show, after the webinar. You will get it automatically. Today it will be Lee who will have the key part. That's the most things the things you've been waiting for to see what he's talking about the new release. Give you a few demos, and me quickly introducing you to what you're going to see. We're now going to switch off the camera because of bandwidth issues. So you have seen us, and we'll come back afterwards again. So we're heading into the presentation. Now, what is the agenda today? The agenda, we're going to have a quick review what we've done last year, and then of course the second release. We had a release in autumn, some quick review of the features, and secondly I'm going to talk about Amberg Tunnel and Amberg Navigator, an overview of the modules and the changes we have made in that latest release, which was released in late 23. Give you a few hints and stuff which we've done, new features, enhancements by module. And then the most important part you've been waiting for definitely is the live demo, where Lee is going to take you through workflows, most important ones. There have been so many changes. We had to focus on really the most important one, and definitely the focus one will be on tunnel scan positioning. So stand by and enjoy the show afterwards, and then we have a quick wrap up, your resources where you can download the links, etc of Amberg Navigator 2.25. So in the spring release, that was in I think May last year, that was a 24. It was a major release. This is where we initially had the support to import model, means IFC 3D models import. That was the first one, because the more and more we see you as a contractor, the contractor is getting more 3D model IFC instead of the WDX, DXF or XML. So we're supporting, since last year early, we are supporting IFC import. And an important one, we improved the point cloud performance. As the point clouds, as the scanners get better, the point scanner gets more dense, and we want to extract more information out of the point cloud. So we had to increase the performance and tweak a little bit. So that was much more performance for your comfort to work with point clouds. On the Amberg Navigator side, we introduced the BLK 360 Generation 2. Remember, the BLK 360 had a Generation 1, which is discontinued now. And then the moment we were able to support the Generation 1, Leica said, hello, now we have Generation 2, and we had to rewrite the whole SDK. So it was supported by then, and we introduced as well a new all-task license, which comprises all 28 Amberg Navigator license, including the support for the total station and also the data exchange, which Lee is going to talk about later. That was the first release in 23, and in the fall release, we then had Amberg 2.25. That's the one we're going to talk about in more detail. Yes, there will be, that's the second step in IFC, enhanced support with OBJ files so that we can, for example, export and analyze an analysis into an object file, OBJ file, and re-import it as an as-built to to a model, so we can do as-built to as-built comparison coming from the IFC channel. Then the much important and awaited one was also, instead of using black and white, to have sphere target georeferencing. And that was for the most important things in Amberg Tunnel. And on the Navigator side as well here, IFC and OBJ is supported, and as well sphere target georeferencing. So today with Amberg Navigator, you are able to georeference 3D point clouds at the tunnel face without a total station. So you georeference, you analyze, and you stake out on the break, for example, in a glass ground scan. And this is possible without a total station. We're going to see how that works. Now, quickly an overview of Amberg Tunnel. We have a bit restructured. So this is the office side. You know, Amberg Tunnel exists. Amberg Tunnel, office size, Amberg Navigator is the on-site tool we're using. So on the office side, we have the so-called base. This is the Amberg Tunnel platform where you enter all your project data, your access, your theoretical design, etc., etc. On top of that, you have then the profile basic or profile plus analysis, tunnel scan basic or tunnel scan plus analysis, and as well geotechnics plus or basic, which they all reside in the same ecosystem called Amberg Tunnel 2.0. Means we have a single source of truth. So all data comes in. If it's a 3D point cloud, if it's a profile or geotechnical data, they all reside on one base, which is called Amberg Tunnel 2.0. Plus, we have add-ons, which we call Navigator tasks. So that's where you define all the tasks for the Navigator, which later needs to be executed, staken out, or taking measurements, scans at the tunnel face. Plus, then we have the cloud sync. This is the data exchange. Lee is going to show you a little bit more on that. And also the cloud project, which is on the collaboration side, where you can collaborate on the same project which resides on the cloud, and people can access that from various locations. The little red dots you see, these are the numbers of new features we have implemented in Amberg Tunnel in the various modules. And you can see tunnel scan, we have implemented 18 of them. Quickly, what we have introduced in the base, like I said, enhancement, OBJ format, 3D view, etc., tables, PDF reports. I'm not going to read this down. I'm only going to show you, this is the one we're going to have a little more detailed live demo on that. On the tunnel scan, there are 18 of them. And you can see there are a lot of improvements we have done. We are going to focus on the first two, the semi-automatic sphere target georeferencing, and then in the point cloud editor, the trim lines, vertical, horizontal trim lines. So we improved a lot, which we have received from our customers input, like to clean a point cloud is the most tedious job to do. So we improved that point cloud editor to give you a easier way to get rid of outlayers and noise. So all in all, you can see we've done a lot of work on the office side. Moving over to the Navigator side, a little bit less, but here just to comprise, to concentrate, these are the 6 different tasks. And again, here, these are the 6 different improvements we have done on the Navigator side. And in this one, we will have that semi-automatic sphere target georeferencing, which Lee is going to demo you right now. So I'm handing over to Lee. Yes, over to you, Lee.
Okay, thank you, Philippe. Can you see my screen? Philippe?
Yes,
Yeah.
absolutely.
Okay. Okay, so we have picked three workflows that we will demonstrate that will hopefully capture some of the main features and improvements we have done. But as Philippe mentioned, we just don't simply have time to go through all of them. So our release notes are the go-to guide to see all of them in detail. But the three we will focus on, the first one is Amberg Navigator Cloud Sync. So this is the data transfer mechanism between the field and the office, the cloud synchronization process that is an alternative to using the USB stick to transfer the project. Now, in terms of the workflow is actually relatively unchanged, but the sync logic and reliability has significantly been improved. So data transfer is the first one. The second one is the new semi-automatic sphere target georeferencing. And we'll take a look at this on both the office side, so in Amberg Tunnel, and on the tablet side. Because maybe on the office side, you're not concerned with georeferencing point cloud in the tunnel. You just want to simply capture it on the device, take it to the office, and do the documentation. Whereas on the tablet side, you're getting the near real-time results in the tunnel to, for example, evaluate the overbreak and underbreak. So we'll take a look at both of those. And then lastly, we'll take a look at the using an as-built mesh as the theoretical design. So this is in a way an enhancement or an evolution of the IFC workflow. So at the time last year when we implemented IFC, we did not call it IFC, we called it the 3D models editor. The idea being that this editor can grow and accept many different types of model files and surface files and so on. So we'll take a look at that. So just before I mention or jump across to my other desktop, I just want to emphasize the difference between Navigator Cloud Sync and Remote Project because there sometimes is confusion about what the difference is. Navigator Cloud Sync is, as I mentioned previously, it's just simply a data transfer mechanism between the office and the field, between Amberg Navigator tablet in the tunnel. The idea being here, or the value proposition, is that the tablet does not need to leave the tunnel. It can stay in the lockup in the tunnel. And from synchronizing, the synchronization process takes care of a two-way synchronization. So if you in the office are making changes to the project structure, so how you organize the project, or you're doing design changes, so for example, the horizontal alignment or the vertical alignment can be changing and often does change. The theoretical profiles are often changing and being updated. The control points, of course, are being added to the network with every blast, for example, and the navigator task definition. So if you want to change your scan capture from medium resolution to high resolution, or you want to change the required accuracy, this is all controlled in the office. So the user in the tunnel does not have to worry about these criteria. So the synchronization process takes care of all changes related to the project itself. And then, of course, at the same time, any field data, field measurements are synchronized back to Amberg Tunnel and get imported or injected into the correct structure, into the correct sites, tubes, shafts, headings, and so on. So that's profiles, as-built profiles, point clouds, of course, measured points or just stakeout points that you save, or just individual points, and photos, of course, as well. We have a documentation task that's part of our all tasks bundle that has a documentation task for taking photos, measuring, heading stationing, taking notes, and so on. And there are storage locations for each of these data types in the project. So that's Cloud Sync, a data transfer mechanism, whereas Remote Project is for project collaboration. So you have your in your main office, you have the project locally, and you can synchronize a copy to the cloud. And then people from remote locations, whether that be in another office or someone working in home office, they have full access to the project. They just need a Wi-Fi connection. They can access the project and both read and write capabilities. They can also contribute to the project, just as if they were working locally with the project. So that's the main difference. I just wanted to emphasize that. And now I will jump across to a different virtual desktop. So this is Amberg Navigator tablet, and this is the emulator I have here. And we are already, you can see here, this is our site. We're in a given tube, a given construction stage, and this is the task we're using, all defined in the office. And in this case, we're just measuring some stored points. So you can take a measurement and save any point you want to save. This storage button is available in many tasks, and I've already measured some profiles as well. So once you're finished doing your particular task, we will go back to the home screen, and we want to synchronize the data. So go to the administration section, project management, and here we have synchronized project. We see, for those of you familiar with this screen, typically there is export project here. So in the settings, we have enabled cloud synchronization. And when that's enabled, we have synchronized project. So I'll go ahead and press that. And now you see we have exported 2 profiles and 3 stored points. And now also, for every synchronization that you do, there a log of all the exported data is saved into the tablet, into the project directory. So into how many profiles, points, photos, and so on were exported, and into which part of the project they were exported, so which tube or shaft and so on. We also have, back on the home screen, we have this info button now, which gives an overview of the current project you have loaded, the name, when it was modified on the office side, and which control project ID you're using, and some information about the transfer, export from Amberg Tunnel, export from Navigator, just to give a sanity check to make sure that you're working with the latest project. This has been added. So if I go to the office side, so this is Amberg Tunnel Office, which I already have the project open, the same project that we were looking at on the Navigator side. And in the project tree, at the root level, the very top level, rather than importing from Amberg Navigator tablet via USB, we just synchronize with the cloud, and that gives you a preview now of into which site, heading, and construction stage we have the various data types imported, profiles and some points in this case. And if we go to our data storage within the project tree, we can see we've imported 2 partial profiles. So this is just demo data. So here we have one, here we have another. And just a little side topic, we can right click on any measurements and merge them and delete the original, for example. So no need to manually handle the individual profiles. They get automatically brought to the correct place. Photos, we did not take any photos, but in this project we have some photos organized by stationing value for documentation purposes. They would get imported into the correct place, and individually stored points as well. So these were the 3 points that were just imported just now into the project. Okay, so if I now go back to the next point. Okay, so the next topic we're going to look at is the georeferencing on the office side using the sphere georeferencing method. So I'll stick with this same project and open the point cloud editor. And here we have 2 point clouds so far. One of them is one is actually a copy of the other one. One is georeferenced, the other one is not. This one, we can see it's georeferenced and it's approximately, or the center of the point cloud is at stationing value 4000 on the axis. And this one is in position 0, 0. And the next step we need to do is to georeference this point cloud. So we're using the sphere georeferencing method. So there's one check we need to do, or one thing we need to make sure of, and that's that the sphere target radius is correct. So I know that the spheres in these point clouds are 10 centimeter radius, so 20 centimeter diameter. So with the point cloud selected in the properties windows, we just need to set the sphere target radius. So I'll go ahead and put 0.1. And that's all we need to do. So the next step is to, from the context menu, or what I prefer to do is right click and choose the relevant georeferencing method. So this is the one we're looking at today, reposition spheres. And now what it is doing is creating a panoramic image, or a grayscale view of the point cloud, which will allow us to easily pick the spheres. So on this screen, I'll hit next. And this target pick screen has been improved. It now opens in full screen mode. And to pick a target, we have shortcuts for adding a target, moving a target, and deleting a target. We also have a zoom extents shortcut, which is Z, and we have a zoom window. So typically you can pick these 3, or in this case we have 3, but you can pick them in a matter of seconds. I think this workflow, if you were just doing it yourself and not explaining, you could do it in 10, 15, 20 seconds, no problem. So we just need to zoom in and pick the target approximately. So the keyword here is approximately. The software will automatically search the point cloud and detect the sphere and automatically calculate the sphere center. So there's no manual picking. So panning and zooming, but what's much better is now we have a right click zoom window. So right click, zoom and release. So here we see one sphere, and we just need to pick anywhere on the sphere. So I won't pick the center, I'll pick a little bit to the left. And what we expect and what we have here is a blue crosshair. The blue crosshair means that it has automatically searched the 3D space and found the sphere and automatically calculated the center of the sphere. If, for example, I'm going to click over here, we do not expect to see a blue one, we see a red one. It searched the area and it could not find a sphere, which is actually what we expect. So we found one. We just need to now select 2 more. So I'm going to hit Z to zoom extents. And I know that the next one is down here somewhere. I can see it already, it's here. And I'm just going to select it. Blue, that's good. Z again to zoom extents. And the last one is on this side. It's here. Select this one. And once you select 3 or more spheres, it automatically tries to find a geometric match between your locally picked points, or the local sphere centers, with your control point list. So it is determined that this is point ID or control point ID F06. If I hit Z, yeah, it has found F1, F3, and F6 automatically. So it's a very easy workflow designed for repeatability to spend as little time as possible doing this daily georeferencing of the blast events, for example. We only have 3 spheres in this case. If we had more, we could of course pick another one and it would find the geometric match if it exists in the control point list in the project tree. So we are done here. So we're ready now to go to the next step. And this is our familiar georeferencing resection residuals, for example. We see this screen on the total station resection results. We also see it when we're repositioning profiles. If the control points update, for example, it's the same interface. You can see our deviations to the individual points, control points, and the overall position of the point cloud. So in this case, we're moving from 0, 0 to our tunnel coordinate system. And of course, we can turn off control points that are throwing out our results. We're quite limited in this case because we have only 3. We need a minimum of 3 to georeference. So I'll go ahead and accept, and that is the process complete. You will see now within a few seconds that this NA will jump, and we are positioned here now on the axis. And if we take a look in the properties window, we have this new category here called positioning, which gives you the resection residuals now in a convenient location. You can also right-click and choose the option black and white or sphere report. So put that on the desktop. And it's just a simple report showing the registration results, which you can attach or accompany with your handover deliverables, your as-built point clouds, for example. And that's the process complete. So it's very straightforward workflow. I'll open up the point cloud to go into the detail editor. And here we have a lot of changes to this editor. For example, now 3D navigation is more intuitive. It's the z-axis always remains level or upright, and it does not become tilted. You can disable this behavior to revert to the previous behavior. You can revert it in the settings, but this is now the default behavior. If we right-click, we have here a reorganized context menu with new features. So for example, selecting by polygon inside and outside. So a selection or an inverse selection, or selecting using any one of the filters we have and then adding or removing to that selection. This has been added. Down here, we've also added the ability to cut a selection to another construction stage. Previously, we had copy selection to another construction stage, but now we have cut. So a typical workflow here might be, for example, here we can see with this, this is colorized to emphasize the difference between the shotcrete surface that we have here, and this is a new excavation. So for example, if you wanted to just select this excavation surface and remove or move it into another construction stage, you can do that, and then you might go into that construction stage, remove the face and put that into a face construction stage. Because then in the point cloud analysis, you can then join up or unify the excavation surface, for example, in a simple workflow. So these are some examples of the features that we have added. One of the main ones is what we have here. We have a new filter, which is the trimline filter. So for example, it filters based on using the 3D alignment as the guide. So you can filter below the alignment or above the alignment, to the left or to the right. An example of where you might use this is even before we get to this point, before we open this editor, you can access these filters, and you might, for example, want to remove the ground, or if you're in a cut and cover construction methodology, you might be only interested with maybe the ground only, so with the data within a certain horizontal and vertical distance from the axis. And these, we can have our usual select and invert select, and these can be used in combination with all of the other tools. So we can use them in combination. We can also, the design offset filter, for example. This is an existing functionality. The planes filter, all of these can be used together. And then the last one is the radial distance filter. So simple tools based on the tunnel geometry to help simplify this process of cleaning. Okay, so that is the process or the changes on Amberg Tunnel scan. They're the ones that we want to emphasize here. I will now jump across to Amberg. I will now close this. I'll jump across to Amberg Navigator, and this time let's look at the positioning workflow using the touchscreen, using Amberg Navigator directly in the tunnel. So I'm using the emulator here, but I'm using real data. So at this point, when you press go, it will start up the scanner. It will fully control the scanner. No other software is required. It will capture according to the resolution we have specified, whether that's 1 minute, less sometimes, or more. Once it has finished the 360 scan, that data is streamed or synchronized back to the tablet, and within a few minutes, less, you're at this point. The tunnel crew is at this point. And this workflow is very similar to what we just saw on the office side. The only exception is we're using a touchscreen, and where I have the mouse cursor, this, for example, would be where you tap the screen. So it's saying we have 0 spheres verified, so we just need to tap somewhere. I can already see a sphere over here, but once you tap, it will zoom in an increment. So select, it zooms in and places a red crosshair, and you just usually tap 2, 3, 4 times, and that's enough to place the crosshairs. And this is sufficient. Again, it's going to automatically snap to the middle once we accept this placement. We're looking for a blue, and we have it. And now we just need to repeat the process. Here we have one that's quite far away. I think this one is 25 meters or something like this away. And this is a medium resolution, not a terribly high resolution scan. So I'll go ahead and accept this one, and the third one is on this wall here somewhere. Yeah, here it is. Go ahead and accept this one, and now this play button has turned green. Green means to the tunnel crew that the required accuracy has been met according to how you predefined the task and the quality settings. So now it's telling us that it's found a geometric match, which are these control points. And when we select it, we have very similar resection residuals to what we saw on the office side. Here I'm working with the same point cloud, just for demonstration purposes. And now it's georeferencing that point cloud, and we can then see the results. So from start to finish, we can get our overbreak and underbreak analysis within a matter of minutes. And the important point here is that you don't need to be a surveyor to do this. This can be operated or understood and used by tunnel crew, people working at the tunnel face. So this is our standard point cloud analysis. This is the blast scan analysis in this case. So we have our overbreak and underbreak, our color scheme according to how we defined it. We can jump to the heat map view. Again, you can completely customize these colors to represent the deviations that you want. We can go back to profile view and navigate forwards and backwards through the profiles. And if you're working with a connected total station, you can then point the total station to the selected point. And that is, yeah, that's the complete workflow. Then once you are done, you can synchronize the data back to the office, and that data will appear into the project already georeferenced. Okay, lastly, I will open a different project, Amberg Tunnel project, to just take a look at the using an as-built mesh as the theoretical design. So this is an enhancement of the IFC workflow or 3D model files workflow. So for each site, we have this 3D model of files editor. And in this editor, this is essentially like, you can think of it like an IFC viewer, where you can take in one or multiple IFC files. You can look at them in context, and then you can decide which surface geometry you want to use as the theoretical design. So you assign it to a construction stage, and then you can use your profile analysis, your point cloud analysis, and so on. So it's a very simple way to work with design data. We now have the import of OBJ format. No, I have an issue here, which is something to do with my, let me just quickly, need to quickly restart Amberg Tunnel. It does not like something to do with the virtual desktop that I'm using. Okay, let's try again real quickly. Okay, so I'll go back into this editor. And what we want to do is, or what I was trying to do just before, is to import an OBJ file. And the OBJ file will get treated the exact same as any other surface geometry. So, for example, one particular workflow you could do is to go to a point cloud analysis. And from the point cloud analysis, I think we have a good example here. So here we have the deviations all to that IFC file. We can go to the 3D view, turn on the axis, and we can look at it. But what we can do is export from here into, select the construction stage you want to export into. And in this case, let's extract profiles from this is fine, from 200 to 250 every 5 meters. We'll downsample the profiles. We don't want all of the scan points. export those. And those profiles now you can go straight to the connected profile analysis, and we have our profiles. From here, you can select, for example, profiles to form a mesh, and this mesh actually can be exported in OBJ format. So, and then this is just one example. This then can be imported into the 3D model files as it's just treated like a mesh in the same way that these are treated like a mesh, and it can be assigned. Here we have it imported, and we can do whatever we want with this. So we can do it to have very nuanced type analysis, to compare the different layers, for example, we can send this design to Amberg Navigator and then use point check to do deviations to an as-built mesh as opposed to a design mesh, for example. So that is everything. I think I'm quite okay on time, Philippe. I think that's me done.
Yeah, you're fine. I think yeah, you can
Yep.
now maybe go
Maybe
over
if
to
I have
the slides. Yeah.
if I have a second, I can just very quickly go back to our slides and just point out that some points about the distance from the scanner to the sphere. It depends. It depends on the hardware you're using, and it depends on the sphere size and the distance to the sphere. But just as a rough guideline, we would say that with the BLK 360, anywhere from 10 to 15 meters you can get highly repeatable results. After that, we have 3D point accuracy issues coming into play, but 10 to 15 is quite good. Then for the RTC 360 or the Faro, here, yeah, depending on the configuration, it can be 20, 25, 30, or even more than that, and you can get highly repeatable results. And lastly, regarding the sphere offset. So one of the questions is, for example, you're using the Leica round prism and your whole control point list is in reference to the center of the round prism. And how is this going to coincide with the sphere you use? You can get the correct adapters and brackets to easily work with a 100 millimeter diameter sphere as well as a 145 millimeter diameter sphere and maintain the same control point coordinates. So if you have some questions about this topic, we've done quite a bit of research on this, so please do reach out to us. And yep, that's everything, Philippe, if you want to take over.
Thank you very much, Lee. Thanks very much. I hope you got a bit of an idea of what we've done. So some 1 minute left. So just quickly wrap up about the resources. I want to talk about where can you get the details here. So this is one of my favorite part. The full format release notes. I mean, Lee, like he's a smart cookie, he's spending hours to do a nice release notes, and we found out the least amount of people read it. So here is a QR code. Take it and sit down, take a cup of coffee or a cup of tea, and read the release notes. It's very nicely illustrated. So all the points you've seen now at the live demo will be explained in more detail. But you can see how much work we put in, and we're still putting in. So there are more releases coming up. So here is a full format release note where you can download. Now, for those who don't know yet how it really works, we have a set of YouTube, so you can also go on YouTube and find out how to get started with Amberg Tunnel. And if you really dare, then you can even request for a demo license, so you can get a look and feel of Amberg Tunnel, and then of course subsequently use the YouTubes in order to get a bit of an idea of how it works. Yeah. So you can get these codes, these QR codes on the recording, and you can take them later. Important for us is like we want your feedback. If we have triggered any ideas, like that's actually interesting. We could improve our workflow. So it doesn't cost you a thing. Just get in contact with us, get online with us, And if it's a technical thing, you just can contact Lee. And if it's a commercial, you want to have a quote, you want to get a budgetary offer, you can contact me. Uh, like this is what we've been doing. We are doing only tunnel. We're very, very much passionate about it. And I think this concludes our today's webinar. And we just have to say thank you very much for your attendance, and hope you get some ideas, and we hope you get some inputs from your side. So get in touch with us if there's anything. Give me a second. I maybe should quickly switch on my camera to say bye-bye. Again, thank you very much for your attendance, and look out. If you're not connected with LinkedIn yet, go on LinkedIn, Amberg Technologies, and stay tuned with all the novelties we're going to and we have in the pocket for you in the coming. That's it. Have a good day, and thank you very much. Thank you very much, Lee. Bye bye for
Yeah,
now.
thank you. Thank you, everybody. Bye bye.